All right, we're going to talk about chemical reactions and quantities, which is just another word for stoichiometry. All right, so first of all, balancing equations. Remember that you have to have the same number of each type of atom on the left and the right. And the only way to do that is to actually change the coefficients. All right, so remember that your reactant atoms equal your product atoms. The coefficients don't have to be the same, but with the subscripts and everything, they do have to add up. Okay, so a couple of tips for me are to first balance your polyatomics. If they stay together on both sides, that kind of makes it easier. And then balance polyatomics first. Okay. I also recommend to do pure elements last, like oxygen. Pure elements last. Okay. And if you end up with a whole like even odd thing, like 2 on one side and 3 on the other. Okay, so if you have even odd, then I would just double everything and then go back and rebalance, or double the large molecule and then go back and rebalance. Okay, because it's probably going to be like a 2 and a 3, and you'll need to bring it up to 6 or something along those lines. So if even odd, double, or essentially what you're doing is looking for the least common multiple. So if even odd, double, or look for least common multiple. All right, so I think you guys can do that. So go ahead and pause here and get the right answers for these equations. So I got here 4 and 3, and then 1, 5, 3, and 4. Okay, I did say do polyatomics first if they stay the same on both sides. So in the A, PO3 and PO4 are not the same polyatomic ion. So I actually didn't do those first. All right. So now on to stoichiometry. Okay, so in order to do stoichiometry, you have to be able to calculate the molar mass of things. This is pretty easy, right? Use a number on the periodic table with decimals. Okay, so use number on PT with decimals. Okay, that is the atomic weight or atomic mass. Okay. Remember, this is the definition is molar mass or atomic mass or whatever you want to call it. It is the mass of 1 mole of that substance. Okay, so that is the mass of 1 mole, okay, of that substance. The units for those are grams per mole, right? Mass of 1 mole. Now, if you're talking about on the atomic scale, though, it is AMU or atomic mass unit. So if I'm talking about like specifically a 1 atom, you would use atomic mass units. Okay, so find the molecular weight of sodium sulfate. All right, you should have gotten 142 grams per mole here. Okay. So that mole, the other thing you need to remember if we're talking on the atomic level is that if I want to know how many atoms or molecules are in something, that a mole is 6.022 times 10 to the 23rd. Again, usually when I'm talking about atoms or molecules, that's the only time you need to use that number is if I ask about the number of atoms or molecules. Okay. Essentially we use this to scale up or to scale down. All right, makes a lot more sense when you're not using these giant numbers to do stoichiometry. All right, so example number 7, this is a conversion one. It says how many molecules are in 1 mole of CH4, and then how many atoms of hydrogen are in 1 mole of CH4. This is a really good review, so I recommend trying this one on your own. I will walk through it in just a moment. So obviously 1 mole of CH4 is just 6.02 times 10 to the 23rd molecules. But if I want to know the atoms of hydrogen, I set this up. You probably could have done this in your calculator, no problem. But I set it up in case you want to refer to this when you're trying to figure them out. So 1 mole of CH4 is what I would start with. That's the number from the problem. And my conversion would be that 1 mole of CH4 has 4 moles of hydrogen because there's 4 H's in every CH4. So it's really just times 4. So 2.41 times 10 to the 24 atoms. Okay, well, I guess what I didn't show there is I was trying to get 2 atoms. So you just need to multiply by 4. All right, so watch your units. You only use 6.02 times 10 to the 23rd when you are trying to get those tiny numbers. Okay, now onto the stoichiometry part. So mole ratios are really the most important part of stoichiometry. Okay, this is the ratio of one species to another in a balanced equation. So ratio of one, when I say species, that can be an atom or molecule, depending on the equation you're looking at. So ratio of one species to another. Okay, specifically in a balanced equation, what are these numbers? They are from the coefficients in the balanced equation. Okay, so coefficients in your balanced has to be balanced, which is why you have to have a balanced equation first. Equation. All right, so if I have my balanced equation like this here, your coefficients are what are going to tell you your mole ratio. You always have to have a mole ratio if some type of chemical reaction happened. Okay, so mole ratios if you have a reaction that happens. All right, so example number 8 says list the mole ratios that can be used for stoichiometry calculations from the following balanced equation. Essentially, you can get 1 to 3, 3 to 2, 1 to 2, 3 to 2, whatever it is that you need in order to answer your question. Okay, so you always want to pull the actual unit out of there. So, like for example, I'm not going to put all these down, but if I have 1 mole of N2 would go to 3 moles of H2, or remember these are conversion factors, so you can write them upside down. So you can write 3 moles of H2 over 1 mole of N2. Okay, that is an example of a ratio you could use in a stoichiometry problem. So when we're looking at these problems, essentially stoichiometry is just going from mass of one thing to mass of another thing. Usually it's mass, it's not always mass. You can also do it with particles, right? How many particles, or volume. We do this a lot with gases. Okay, we use that 22.4 number, 22.4 liters per mole of any gas, but liters of a gas specifically. That's the only time you can use that 22.4 number, okay, at STP. So I like this little diagram here. You can either start at mass or volume or particles. You go to moles, you have to do the mole to mole ratio. Like this part has to happen. And then you can go to mass, volume, or particles, and this tells you how to get there, which conversion to use. Okay, so we are going to, I'm going to do the steps for stoichiometry. The steps are always step 1. Here, steps. Convert to moles. Convert to moles. Very important. You cannot use a mole ratio if you are not in moles. 2, mole ratio. Okay, you always have to have a mole ratio no matter what. If you're not sure what goes on top and what goes on bottom, I like to remember that it's always wanted over given, meaning what you want to find over what you were given in the problem. Okay, and then 3 is convert to grams or liters or whatever, atoms, particles of whatever your wanted is. Okay, so you do have to do those 3 steps at the very least. So if I were you, I would try number 9 on your own and check your answer. I'm going to talk through this answer now, okay? So I started with the number I was given in the problem, that's 2.50 grams of N2. First thing I did is convert it to moles. So in order to do that, I had to get the molar mass. Then I used my mole ratio. I put my wanted thing. So in the question, it's saying, what is the mass of ammonia? So ammonia goes on top. Over my given thing, I started with N2. So N2 goes on bottom. And these here are the numbers for my balanced equation. So this was my ratio. And then the question is asking for mass of ammonia. So I had to go back to mass, which means I needed to multiply by the molar mass of the thing I'm trying to find in the end, which is ammonia. So then in my calculator, you can do this however you want to. You should end up with 3.04 grams of ammonia. Now I did 3.04 because the number in the problem, this number here, 2.50, has 3 sig figs. So my answer should have 3 significant figures.